Okay, I'm going to continue with example 6. I'm going to move this over, and I'm going to draw another sketch to show the same angle, but in a slightly different way. Cos of theta is 1 over 4, so we already know the angle is 75.5 degrees. I'm going to re-sketch it, but this time I'm going to draw that triangle that we're familiar with. There's 90 degrees. Here's 75.5. We know the ratio is 1 over 4. Well, cos of an angle is adjacent over hypotenuse. So since the ratio is 1 over 4, we know that the adjacent has to be 1 and the hypotenuse is equal to 4. So the question is asking us for the sine of that same angle and the tan of that angle. Well, in order to figure these two out, we would need the height of this triangle. Let's use Pythagorean's theorem. 1 squared plus, we'll call this a squared, I think in the lesson it has a y here, but that doesn't matter, is going to equal to 4 squared. Let's solve this as shown on the website there, and we end up with a is going to equal, this is 16. 16 minus 1 is 15. If we take the square root, we end up with root 15. Again, leave it as a radical, don't express that as a decimal. So there's root 15. Now we can evaluate what these angles are going to be. Since theta is 75.5, we know that sine of theta, which is 75.5, is opposite over hypotenuse, or root 15 over 4. Is going to equal opposite over adjacent. So we can say that that's going to equal root 15 over 1, or quite simply root 15. We don't need to put any ratio over 1. So since we have those two ratios, we know what the measure of that angle is, 75.5 degrees. We realized over here that a corresponding angle is actually 360 subtract 75.5. When you did that step, you should have got 284.5 degrees. So that's this angle here. We have to remember that these ratios can also exist for this opposite angle here. So let's show that. I'll move this page down a little bit. So I'm going to put a big or here. We can have the sine of theta. Now this time theta is going to be 284.5 degrees. Now I can show that here too. Okay, there's your terminal arm. We can draw this triangle down like this. Make this a little bit longer. There's that triangle. There's 90 degrees. And again, think about your measurements. Here, the height of the triangle is going to be negative root 15. This is still 1, and this is still going to be 4. So there's your sketch there. So let's look at this angle here. The sine of theta going all the way around is going to be opposite over hypotenuse, which means it's going to be negative root 15 over 4. And tan theta is going to be opposite over adjacent, which is negative root 15. Again, we don't need to put negative root 15 over 1. So whenever you have anything over 1, just leave it as the numerator. So you have the cos of both angles, 75.5 and 284.5, and we easily found the sine and the tan ratios for both of those angles given Pythagorean's theorem. So these are your final answers. This is what I would expect if I was giving you a question on an assignment.